Hey guys, Travis Gillespie here. Today we're looking at adding integers, and in this first example it asks us to write the addition modeled on each number line. So let's go ahead and just highlight that keyword addition, because I want you guys to think addition in just a second. But before we get into this model below, what I want to do is just get a small circle drawn up on the screen. And this small circle, it's going to represent an integer chip, and we use integer chips when dealing with adding positive or negative numbers together. So the first chip I'm going to shade in with red here. So shade that in red, and we're going to call these our positive numbers. And let's fix that E real quick at the end. So positive numbers there are red chips, and I'm going to use blue to represent our negative chips. So if you have a positive number, it will be a red chip. If you have a negative number, you can use a blue chip. But let's look at this model displayed over here. And we've got our number line, and whenever dealing with the number line, you always start at 0. So starting at 0, I'm moving to the right. This arrow is moving to the right, and it's moving 1, 2, 3, 4, 5 units to the right. So the first thing I want to do is just write that down. I'm going to write down moving 5 units to the right. Since I'm moving to the right, my values are getting larger than 0, so it's a positive 5. So I'm going to make a note that this is a positive 5. So what I want to do next is I'm going to draw 5 positive integer chips here, and I'm not going to get fancy with it, so I'm just going to draw 5 circles over here. So I have 1, 2, 3, 4, and 5 positive integer chips. Let's go back to our model here. So we're at positive 5. The next thing we're going to do is add. Remember, we're adding, so I'm going to make that note. I am adding, but it looks like the arrow's changing directions. It's going in the opposite direction. Since we're going in the opposite direction, the next thing I want you to think about, since it's the opposite, is we are going to use the negative integer chip. But since we're moving in the opposite direction, I'm taking numbers away from 5. I'm moving away from 5. I'm losing values. So let's take a look at how many values are lost here. There are 1, 2, 3, and 4 units lost. So I'm going to just add a parenthesis here, and inside the parentheses I'm going to write that we're taking away 4. So taking away 4. So now let's go ahead and put 4 negative integer chips in our model below here. So I'm just going to put 4 down. 1 and 2 and 3 and 4. So we're going to use these integer chips in just a second. I'll come back to them. But let's go back to our expression, 5 plus negative 4. Well, what does this equal? I'm going to get my black pen here and look at my model. Well, I started at 0. We gained 5. Then we added, taking away 4. That's the same as 5 plus negative 4. And the arrow stopped at positive 1 on the number line. So 5 plus negative 4 has to equal negative 1. So negative 1 is our answer, but now let's move over to our integer chips. How could these integer chips help give the value? Well, when you add positive and negative integers, you know that opposites cancel out in math. So a red chip and one blue chip, they should cancel each other out. So one thing you could do is just cross them off. You could cross them off one at a time until you run out of chips to cross off. Well, that might take a little bit of time if you have a lot of chips drawn up on the screen. So another thing you could do is just box up the chips that match each other. So if you have one red and one blue chip, just box up the ones that match up with one another until you run out of chips that match up. And anything that's left outside of the box should give you your final answer. So we're going to pretend that everything inside of the box here, you don't have to cross it off after that, but we're just going to pretend that these all canceled out. So what are we left with? We're left with one red chip. Well, a red chip is a positive integer chip, and we can see that I'm left with one red or one positive integer chip, which means my value, my answer should be positive 1. Okay, so I'm just going to write 1 over here. So let's actually see if my model that was drawn with integer chips matches my other value. So I've got to check both values here, and I'm actually seeing that there's a mistake. My integer chip, I was left with one positive integer chip. I'm being told my answer should be positive 1, but when I actually look at the answer when adding 5 plus negative 4, I wrote down that the answer is negative 1. These don't match up. There's a mistake somewhere. And I can see my mistake is here where I wrote negative 1. If I go back up to the number line, I think it will make a little bit more sense again. So we start at 0. We gain 5. we stop at 5, and then we add, taking away 4. If you take 4 away from 5, you can see the arrow doesn't stop at -1 on the number line, it stops at +1 on the number line. So all I have to do is make a quick fix and erase that negative symbol. Okay, so we can see here that 5 plus -4 is equal to +1, and we can box up our final answer. Now you might be asking yourself, do I have to do all this work every single time I'm going to add positive and negative integers? Well, no, the truth is our overall goal in the long run is to be able to do mental math, to be able to practice so many times adding and subtracting positive and negative integers that you can visualize all of this work in your head so that you don't have to draw it up every time. But you can even see that I just made my own mistake. I was trying to do this in my head, and I wrote down that the answer was -1, when in fact it was +1. And the only reason I was able to catch it is because I had a model in place here. And that's the power of math. That's what's really cool. You can use the models or not, but they are only there to help you out. Cool stuff, guys.